You change one line of Python code, you rebuild your Docker image, and Docker reinstalls every single dependency from scratch. 3 minutes wasted every single time. Today I will show you the two-line fix that makes Docker cache work for you instead of against you. Welcome back to the kingdom. This is image number 5 in Docker, 100 images, 0 to architect. I am Himanshu Gupta. Last time we learned how to install software inside image with lean run command run. Today we learn two new instructions in Docker 18 instructions, that is copy and workdir. Copy gets your code into the image. Workdir tells Docker where to put it. Simple on the surface, but the order you write them in has massive consequences for your Docker speed. Here's the plan. We build a Python Flask web app from scratch. We Dockerize it the naive way first, and then we will break it. We will break our cache. Then we fix the order and we watch Docker skip the slow steps. By the end, you will understand build cache optimization, a skill that separates people who use Docker from people who understands Docker very well. So let us go. Again, we are in our images folder. You can clone the repo Docker 0 to architect from the description where we have GitHub link. Now let's see what's inside images folder. List. So let me remove this folder I just created 005. So we do it from scratch. So you will see like there are 4 folders for 4 images we created earlier. So this is the fifth folder. This is the 5th image. So we are going to create a 5th folder for it. And the name of mkdir 005 and py app, because we are creating a Python app right now. Let's go inside 005. So here we are going to add all the files which is needed to create our 5th image. Okay. And about the project, we are building a Flask greeter app. Flask is a lightweight Python web framework. You do not need Python installed on your machine. That is the beauty of Docker. The container has everything what we needed. So let us write our first application. So vi app.py, and let me put the content here. So if you see the content here, we have 2 routes in our application. First is the home route, which is defined here. So home route gives instructions, and the greet route, that is the second. So greet route takes a name in the URL and says hello. The host is set to 0.0.0. So it listens on all the interfaces inside the container. Very important, because otherwise Flask only listen to a local host inside the container and your port mapping cannot reach it. So let's save it. WQ, oh, not capital, WQ, enter. Now let's also create a requirements.txt. This is like dependency what we need for our application, and inside that we only have one dependency, that is Flask, pinned to a specific version, that is 3.1.1. So our builds are reproducible. So in production you always pin your version. Never just say Flask with no version. Your build should produce the same image today, tomorrow, and after 6 months also. So let's save it. Okay. Now, let's first explain work dir instruction in Docker. So let me go here, create a file demo.txt. Okay. So this is the keyword we are going to use in this particular video, and we go very deep into this. So before writing a Docker file, let me explain what work dir is. So work dir sets the working directory inside the image. Think of it as a permanent CD. Every instruction after work dir, every run, every copy, every CMD happens relative to that directory only. If the directory does not exist, Docker create it automatically, and you do not need a mkdir first. So we do not need instructions like mkdir to create a directory inside Docker. If we are using work directory, if the directory is not available, it will create it. So most Docker files set work directory to mostly people use dir set to either slash app path or slash src path or slash like opt slash my app path. So it keeps our file organized. Instead of dumping everything into the root directory, we use a particular folder, and workdir will create it for us inside the Docker. So now let us start with how most beginners write, and we will call it like a Dockerfile.name, and later we are going to see how optimization work. So let's go create a file, Dockerfile.name, and insert mode, and this is our content of Docker file. I'll save and exit later. So let me break this down for first line by line. So first instruction is like from Python 3.1 to Slim. That is our base image, Python 3.12 on a Slim Debian variant. Slim means they stripped out extra packages to keep the image smaller. That's very good practice. Then the second line is workdir slash app. So from this point on, everything happen inside slash app, like Docker created for us. The third instruction is copy dot dot. So copy dot dot, this copies everything from our current directory on our host system into slash app. So second dot means like current directory inside the container, that is slash app we given here. Okay, so the first dot is the source host and the second dot is the destination, that is like container relative to work dir. Now uh, the fourth line, that is the uh, uh, run instruction, like run pip install. So that will install our Python dependencies, and then followed by no cache directory. So flag that tells pip not to store downloaded package in cache. And similar to what no it's like same as like no install recommend, which we use in our previous video for apt-get. So which will keep the layers lean. And the last instruction is like cmd command, and that will run our app when the container restarts, or when the container starts. So till now it looks fine to us. Let us build and see. So let me save it. Okay, let me get the content of our Docker file name. Content looks good to me. So let's build this first. For building, we are using docker build -t is for like name of the image, and followed by like if we want to give version, and it is 0.1 -f dockerfile.name, because we did not put the name dockerfile, which is default one, so we have to put the whole name. And build context, take whatever directory we are in for each and every file. That is the build context here. Okay, now enter. So watch the output. Pay attention to each step. Notice that pip install downloads Flask and all its dependencies. This takes like few seconds, and now let us run it to make sure it works. So let's build the container out of it. That is docker run -d in detach mode hyphen name of our container will be uh, greeter uh, test. Port we are giving 5003 to 5000 inside the container, which we already put in py dot like in a Flask app. And name we are giving for our container, oh sorry, we are using image py app nave 0.1. So let's enter it. Oh, it got created. So you run docker ps. You see your container is already here. Now let's see and test. So also I will show you the, so if you see app.py, we have like two things. One is return welcome to the kingdom, visit greeter username, and whatever name we will put, it will show that particular name also. Okay, so let's curl http localhost 5002. We put 5003 and enter. So you will see welcome to the kingdom, visit greeter, greet like whatever name we put. Okay, and let's run the second call http localhost greet kingdom. Whatever we are putting it here, the name will directly go, and it will show. Wait, it's 5003. My bad. You will see hello kingdom. The kingdom welcomes you. So in this one, hello kingdom, so whatever name we put, it just update that name like greet kingdom. So it update hello kingdom, and kingdom welcomes you. Okay, so our app is running fine. Our Flask app is running inside a container and reachable on port 5003. So let's stop it for now. For that, we use Docker to rm-f uh, greeter test. Okay. Now Docker ps to see if container is running or is in exited mode also. No. So that's fine. Like we have removed the container. Now we have the cache problem which we are going to solve. Okay, so now I will show you the problem and watch carefully. Let us make a tiny change to our application, and then th- and like just change the greeting text in app.py. Okay, so here is our gre- greeting text. So from hello to we just enter greetings here. So we just change a single word, okay, and save our app.py and try to rebuild it again. So let's rebuild with a new uh, 0.2 tag. So same command, docker build -t 0 dot and like hyphen t py app name 0.2 hyphen f dockerfile.name. And once we enter it, so watch the output carefully. Look at the copy step here, and it says it is not using cache. And because copy invalidates the cache, and the next step, that is pip install, also runs from scratch. It re-downloads and reinstall Flask and all its dependency, even though we did not change requirement.txt at all. This is the problem. Copy copies everything. When anything changes your Python code, a README, or even a comment, Docker sees the copy layer is a different and busts the cache. uh, every layer after the busted one also rebuilds. So pip install runs again from for no reason. On a real project with dozens of dependency, this turns a like 2 second rebuild into a 5 minute rebuild. Every single time you change a line of code, that adds up very fast. Now let's create a optimized Docker file and see the differences. So here is the fix. Let's clear it and vi Docker file. Okay. And let me put the content in insert mode. We will save and exit it later. So the difference here is the two lines, but those two lines change everything in this code. We split the copy into two steps. Okay. First, we copy only requirement.txt. Then we run pip install. Then we copy the rest of our code. Okay. So why does this work? Because Docker caches every layer. If requirement.txt has not changed, a copy requirement.txt layer is cache hit, which means the pip install layer is also a cache hit. Docker skips both instantly. Then when it hits copy, this one, like copy dot dot. Yes, that layer rebuilds because our code changed, but pip install already finished. It was cached. We skipped the slow part entirely. So the rule is copy things that change less often first. Dependencies change rarely. Code changes constantly. So copy dependency, install them, then copy code. This order respects the cache. So let's save it and build again. So Docker build. Here we did not giving hyphen f and Docker file name because we just put Docker file. It will take whatever uh, default Docker file is there with this name. So in our first build, you see everything runs and pip install download Flask, and this is cold build, same as before. Okay, now we need to see the magic. For that, we change a one line in app.py. So this time we are changing the home route where re- we change welcome to the Docker kingdom instead of kingdom. So just add something so that it will change something, and then control is save it. Okay. Now let's rerun it again. That is Docker well hyphen t for name and tag, py app, and version is 0.2. Okay, and build context this folder. Now watch the output and read it carefully this time. The copy requirement.txt cached, that is uh, so you see this copy requirement.txt got cached. Run pip install also got cached, and work directory app is also cached. Now copy dot dot this only runs. So this, because our code changed, so copy dot dot will have to run again, and cmd also runs. So that build took seconds, not minutes, and the slow pip install step was completely skipped. This is called as a cache optimization, and you just learned it on image number 5. So now let's run the optimized image again. Like let's build the container out of it. So for that, like docker run hyphen d in detach mode hyphen name greeter, and we will be putting 5005 uh, to 5000 inside the container. So let's build it. Now let's try to run the curl. 5005. You see, welcome to the Docker kingdom, which we just updated. And let's put Docker here. So wait, 5005, my bad. Okay. So greetings, Docker. The kingdom welcomes you. It's working perfectly. A real Python web application running in a container with optimized build layer is there now. So now we have one more important point here, that is copy versus add. Now, quick but very important. You might see add in some Docker file. What is the difference between copy and add? So copy does no like copy does one thing, that is copies file from host to image. That is it. Simple and predictable. Add does the same thing, but with two bonus features. One, if you give it a tar archive, it automatically extracts it. And second, it was download like it can download file from an URL. Sounds useful, right? But here's the advice every Docker experts give, like use copy unless you specifically needed. It's add superpowers. Why? Because copy is explicit. When someone's reads your Docker file, they know exactly what copy does. With add, they have to wonder: is this extracting a tar? Is this downloading something? Explicitly is better than clever. So rule of thumb is copy for files, add for when you need tar extractions. Now let's go to lazydocker and see what we have done. So let's go to terminal, lazydocker. Now in lazydocker, let's navigate to images and find py 2.0. When you click into it, look at the layers here. Okay, you can see the WorkDIR layer and the copy requirement.txt layer, and the pip install layer and the copy dot dot layer. Yeah, like each one clearly separated. Each one is independently cacheable. And now check Docker history from the terminal. Press Q here. So Docker history py app 0.2. So you can see every layer and its size one by one, and what creates it. The copy requirement a requirement.txt layer is tiny one. It's just 13 byte and just a text file. The pip install layer is larger one. If you see, uh, uh, it's like 13 MBs, and that is where the dependencies live, and the copy layer is the small, just our app code. This separation is the whole point. Now, one more thing before we wrap up. When you run copy dot dot, uh, it copies everything in your directory, everything like your .git folder, your node modules, your local virtual environments, files you never want in your images. The fix is a file called dockerignore. So let's clear. So what it does, it works exactly like .git ignore. You list patterns and Docker skips them during copy. So let's create vi docker ignore file, and we will add whatever we want to ignore insert mode, like pycache.pyc.get.env, and then save and exit. Okay. No, the interview moment. So interview question will be, interviewer shows you a Docker file where copy dot dot comes before run pip install. They ask, what does copy order matter in a Docker file? Here's the senior level answer. Docker builds image layer by layer from top to bottom. Each layer is cached. When Docker detects a change in one layer, it invalidates the cache for that layer and every layer below it. If you copy all your source code before installing dependencies, and code change invalidates the cache and forces a full reinstall of dependencies. Even when the dependencies have not changed, by copying the dependency manifest first, installing dependencies, and then copying the source code, you ensure that dependency installation is cached independently of the code changes. This dramatically speeds up uh, iterative development builds. The answer shows you understand the build cache and you understand layer invalidation, and you have actually felt into pain and solved it. This is what interviewer wants you to hear. Now let's wrap up, recap on our fingers. First, we worked on workdir, sets the working directory inside the container. If it does not exist, Docker creates it. Second, like copy brings files from your machine into the image relative to workdir. Third, like order your copy from least changing to most changing, because dependence is first and code second. Fourth, the Docker build cache invalidates from the change layer downwards. Respect the order. Fifth, copy and add instructions unless you need tar extraction. Homework: add a docker ignore file to your project. Put pycache .get .env in it. Rebuild the image. Compare the image side before and after. Post your result in comments. Next time, image number 6, like CMD versus entry point. You have been using CMD in every Docker file so far, but there is another instruction called entry point, and the way they interact is one of the most misunderstood concept in Docker. We clear it up. That is next. If this helped, subscribe and join the kingdom. 100 images, one concept at a time. and we are 5 down, only getting sharper. And remember, don't be the same, be better always. Thank you. Bye bye.